All right, good morning, gentlemen. As you know, yesterday it seemed pretty easy. I hope you got the hang of knowing what the amplitude and the vertical shift of a sine function was. Today we're only going to be looking at the frequency and the period of a sine function. All right, so yesterday we were working with A and D, and today we're working with C. So, like I said, if you recall, right, we have that y is equal to a sine, right, and then parentheses, bx plus c, minus c plus d, right, plus t, where a was equal to our amplitude, b was equal to our frequency, c is a horizontal shift, or they're also, another word for it is the phase shift, and d is equal to our vertical shift. So yesterday I only focused on amplitude and on the vertical shift. Alright? Today's lesson is only going to be based on frequency and the period. So frequency and period go hand in hand. Alright? So I'm going to tell you how we're going to do that. So first off, let's do the vocabulary. So for a period, right? A period is the length of each wave the interval, right? It is normally two pi, right? Whenever there's nothing, when there's no numbers in front of the sign or anything like that, I mean behind the sign, multiplying anything, it's normally 2 pi. Now, if b is greater than 1 or b is less than 1, where b is frequency, then, this is important, then your period, right, your period is equal to 2 pi over the absolute value of b. Alright? So, this is what I mean. Period and frequency go hand in hand. Whenever you go, normally in physics, frequency is 1 over the period, and the period is equal 1 over frequency. Okay? So, they go hand in hand everywhere you go. Everywhere you look at it, they go hand in hand. They're proportional. Alright? They're inversely proportional to each other. Now, if b is greater than 1, the wave compresses or shortens. Okay, so in other words, if the frequency is higher than 1, right, the wave is a lot shorter. So the higher the frequency, the shorter the waves. So if b is less than 1, the wave extends and lengthens. Alright, so in other words, again, if the frequency is really low, the waves are longer. Alright, they seem to be fatter, they go wider. Alright, so this is what we need to know. Now, frequency So this is all I have for period right now. All right. So like I said, whenever you think about frequency, because in this equation, they're not talking to you about the period. They're talking about frequency, but you need to know, right now I'm going to show you why you need to know what the period is. So frequency is the number of cycles it completes in a given interval. It completes, I'm sorry, in a given interval. All right, so now let's get to some examples. This is how we learn. All right, so example. Graph y equals sine of 4x. So now I need you to see something. Notice it's different than y equals 4 sine of x. All right. The difference is here we have this 4 between the sine and the x. All right. So that means, remember yesterday I was talking the parentheses. Well, this is inside. All right. This is different than having the 4 in the front right here is your amplitude. Well, this yellow on the left right here, the one that we're trying to figure out, this is your frequency. All right. This is not your amplitude. If it's not in front of the 4 is not in front of the sine, then that's going to be your frequency and not your amplitude. This 4 right here is in front of the sine, so that's what determines the amplitude. I need you to be very careful. Don't get those mixed up. So remember, just read it from just like you'd read normally. If it's in the front, that's your amplitude. And if it's in front of the x, all right, that's your frequency. All right, I need you to know that. If it's in front of your x, that is your frequency. All right, so we have that. So if we put this side by side so you guys can see the difference. So if I have y is equal to 4 sine of 4x, and I have y is equal to 4 sine of x, right? As you guys can tell, my a here is equal to 1, my b is equal to 4, my c is equal to 0, and the d is equal to 0. While over here, my a is equal to 4, the b is just equal to 1, c is equal to 0, and d is equal to 0. All right, so there's a difference. The amplitude here is 4, on the right one is 4, and the amplitude in the left is 1. So just be careful with that. Now, how am I going to graph this? Okay, there's a great question. The first thing I have to do, all right, is find the period. So this means I'm going to have to find my 5 points. This is going to show me the first wave that I'm going to graph, and then it's just going to keep on repeating. So once I find the first wave, then everything after that is going to look exactly the same as that first wave, because it's repetitive. If you think of a frequency wave, it just keeps on, it's the same shape every single time, nothing's changing. All right, so it's repetitive. So once you find the first wave, it's just going to keep on going forever and ever unless you have an interval. Now, so in this case, if I look back, it says the period is equal to 2 pi over the absolute value of b. So my period, so let me do this. So my period is equal to 2 pi over the absolute value of b. So in this case, I have 2 pi over the absolute value of 4, right? So it's over 4, which is equal to just pi over 2. Now, what this period means, right? This means that the end of the wave is going to be, this means that the end of the first wave is going to be at pi over 2. Okay, this number right here. So this is what it means. All right. So if I think about my graph, okay, if I look at it right here, I'm going to make a big graph. Oh. Okay. Now, we normally start with 0, right? And then I'm just going to go put some 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2. Let's undo this. Let's make it a bit bigger, wider. 1, 3, 4. That's all I need, right? So remember that we need 5 total points, right? The 0 where you're going to start and 4 in between. Now we know that I just told you that the period is pi over 2, so this is the end, right? The last one's going to be pi over 2, and this is going to start here. Now, you're wondering, how am I going to figure out what these points are? All right, well, the way that we're going to do this, okay, all you have to do is grab that period that you found, right? So it's going to be pi divided by 2, all right? And you're just going to divide that by 4. Why by 4? Because those are the 4 points that you need, right? Here we have 1, 2, 3, 4. And at the end is going to be pi over 2. Now, I know we hate. So it's, in other words, the equation is going to be period divided by 4. Okay, this will determine each x value. So now all I have to do is divide that by 4, which is equal to, if you don't like it written like this, it's just equal to pi divided by 2, pi over 2 divided by 4 over 1. Now how do I do this? I just cross multiply. And this is equal to pi over 8. So what this is telling me right here, okay, is that I'm adding pi over 8 to each x value. So the first one would be just pi over 8, right? Because 0 plus pi over 8 is pi over 8. And then the second point is going to be pi over 8 plus pi over 8, which is equal to 2 pi over 8, which is equal to pi over 4 if I simplify. So the next one's pi over 4. Then the third point I have is equal to 2 pi over 8, right, plus pi over 8, which is equal to 3 pi over 8. So now you're probably wondering, Pablo, where did you get, Mr. O, where did you get this 2 pi over 8? From the second point right here, right? Right there, which is the same thing as pi over 4. So this is 3 pi over 8. 3 pi over 8. Okay, now we have our point. We don't have a change in amplitude, so the amplitude is just 1. So this is how we're going to do it. So 0, and then you go here, right? 1 and negative 1, and then it went down to here, and the 3 pi over 8 goes right there, and then it goes back up. So it looks just like this. So this looks very similar, right? But if we were to draw it to scale, it would be condensed. Okay, it would be a lot more frequent, and the waves would be shorter. All right. So this is how we do that. Now let me show you an example. This is an example that I only did when I changed the frequency, but now I'm going to do a little twist in it. I'm going to keep adding a little bit more from what we learned yesterday. So right now I'm about to do with an amplitude change. All right. So for example, all right, I have graph y is equal to 2 sine of 1 All right, let's do our variables. Let's figure this thing out just little by little. Let's take our steps. It might take longer, but this will not get you confused. So we have that a, right, is equal to 2, right here. So 2. Then we have that b is equal to 1/4, right? Now, we haven't looked at horizontal shifts, so we have 0 for the phase shift, and as of right now, we do not have anything back here, right? That will determine that we have a vertical shift. So all we have is an amplitude change, right? And we have a frequency change, right? So now we did that. The first thing I told you to do is we got to figure out the period, right? So the period is equal to 2 pi over absolute value over frequency. So what is our frequency? So our period is equal to 2 pi over the absolute value of 1/4, which is just 1/4, right? So this, which is equal to 2 pi divided by, so 2 pi over 1 divided by 1/4. So if I cross multiply this is just equal to 8 pi. Now, 8 pi means that that's going to be the last value of the first wave, right? The last for the first interval. This is where the first interval is going to end. Now, what I told you to do before is now you have that 8 pi, right, to find each value, right? If I look up here, I told you to find, you're going to have to do period divided by 4. This is to be find x values. Okay, so I'm going to do that. So to find it, I'm going to have 8 pi, so the x values, excuse me, it's equal to 8 pi over 4, which is just equal to 2 pi. Alright, so this is letting me know that each x value of my graph is going to increase by 2 pi. Alright, so if I do this graph once again, okay, so I'm going to do this. So first off, I do have an amplitude change, so that we're going to have to work with that too. But I'm going to do this. So 1, 2, 3, 4. All right. So this is 2 pi, right? And then 2 pi. So the second point is going to be 2 pi plus 2 pi, which is going to be 4 pi. And then the next one, third, is going to be 4 pi plus 2 pi, which is going to be equal to 6 pi, and this is going to be 8 pi. All right. See how the first and the end, the end is the end of our period, right? 8 pi. So that's what we want. Now, there is an amplitude change, right? We have a 2. So all this is going to do is good, like we did yesterday, is going to make it longer, right? At the top, it's going to look taller and at the same time. So I'm going to go here, right? 0, and then I have 1, 2, then -1, -2. Okay, at this point, at 2 pi, we said it goes up to 2, right? Because it goes up to the amplitude. Normally you go to 1, but since the amplitude changed to 2, we have to go up 2. And at 4 pi, it's going to go to 0. And then at 6 pi, it's going to go to -2. And then it's going to go back to it. So if we look back, it is going to be, the shift. So it's going to be, normally it's the vertical shift minus, plus or minus the amplitude, but in this case there is no vertical shift, so that's how we know that we're going up 2 and down 2, so it's 2 and -2. All right, so now you just graph it, just connect the dots, and that's it. Okay. Now, we worked with one with just a period change, a frequency change. We have an example with a frequency change and an amplitude change, and you guessed it, as much as you're gonna hate me, there's gonna be the last example that we're doing today is just going to be a amplitude change, a frequency change, and a vertical shift. Okay, so you got to be careful on how to do this. So this example says graph y is equal to 2 sine of 1/2 x plus 2. All right, so let's start labeling stuff. So our a is equal to 2, right? Our b is equal to 1/2. So our frequency is equal to 1/2. So a, and then the frequency is 1/2. And then our vertical shift is 2. So we don't have anything, we don't have a horizontal shift or a phase shift, so that's 0. D is equal to 2. Okay. Now, again, the first thing we gotta do is when we graph this, it's gonna be a little change. Remember what the vertical shift does? It changes our midline. It changes kind of, we can say that it kind of changes we have a new x axis for where the graph works, but it doesn't take away the x-axis. So what I mean by this is this. All right, so if I graph this, I'm going to do this right here so you guys can see it better with the artwork. Okay, so let me put my labels. I'm just going to do 5, 2, 4, and 5. 1, 2, 3, and 4. Okay, now the first thing I'm going to look at is my vertical shift, right? I have a new midline. Okay, this boy right here. Now it's 2, so I'm going to go to the 2. 1, 2, 3, and 5. So at 2, I'm going to put in this brand new x-axis that I made, right? So right here, just like that. Okay, now the next thing I'm going to have to do is figure out my period. All right, so first I'm going to do that. Second I'm going to do that. So my period is, right? So period is equal to 2 pi over my frequency. So in this case it's 2 pi divided by 1/2. So 2 pi over 1 divided by 1/2 is equal to, so if I do this, is equal to 4 pi over 1, which is just equal to 4 pi. Now that means that the 4 pi is going to be my last point of the first interval. Now to find what each dot is going to be, I just have to divide that by 4, and that's how I'm increasing. So I have 4 pi divided by 4 is equal to pi. So this means that each point, each x value is going to be increasing by pi. Each x value is going to increase by pi. All right, so that means that the first one is just pi. Pi plus pi is equal to 2 pi, and then 3 pi. All right, I hope you know where I got these values from. So the first point is just pi, 0 plus pi. The second point is pi plus pi. And then the third point is just 2 pi plus pi, which is equal to 3 pi. Now, here is where you might get a little confused. All right? So I have this midline, right? I have this midline right here. This is where I'm going to be putting in my points. This is what's going to be acting as the new x-axis. But I'm not going to just ignore the x-axis, all right? So if I think this through, all right, I also have to do my amplitude check. So first off, I'm going to start here at 0, 2, okay? Now, my amplitude is 2, all right? So at pi, right, if I'm going up because it makes it taller, at pi is going to go to 4, right? Because as we did yesterday, it is the vertical shift. So to know the points, it's the vertical shift plus or minus the amplitude for the highest and the lowest value that we're going to get. So my vertical shift here is 2. Then the amplitude is 2, so that we know that the highest is going to get is 4, the highest. Okay, so we go to pi and it goes to 4. And the lowest is going to get is going to be 0. So what does that mean? So if I look here, my 0 is not going to be here. That's 2. All right? The low 0 is right here. So at 2 pi, if we look at how the sine graphs look, it's going to cross there, and then that 3 pi is going to go to 0. Okay? And now it's going to go back up at 4 pi to our new midline. So this is what I mean. Your midline is acting like your x-axis, right? But now this is just different. A little bit different. All right? Now the amplitude changed, right? So then I'm just connected by 2. So there it is. All right? If you have any questions, please don't hesitate to email me about this. I know it can get a little confusing and it's a little tedious, but it's something very important in precalculus. All right, boys, I hope y'all have a wonderful day, and I'll talk to y'all later.